certainly be good to use the hydrodynamic models as well, which I think Ben will talk about later. Anyway, next up we have Dr. Des Whitfield. Des has been working at the Department of Ag at Tajura for 40 years. There's been a few name changes, so Department of Ag is still known at the moment. And for the last 7 years he's been working on satellite crop use water use of crops, and I should say crop use of water, and then the application rate for the environment.
Okay, thanks. So I'm talking about a project that's involved a team of people that, and you can see that there's one name there that stands out. Mohammed is part of that team, and we've been using satellites in combination with a lot of other information. But the aim was that we were going to attempt for the first time in Australia to use seabarometric approaches to estimate ET or water use by crops on the ground or by land surfaces on the ground. And particularly the emphasis at the time in 2007 when we started this work was that we want to investigate the possibility of using Landsat information to get some understanding and quantify, if possible, water use and irrigation water requirements of crops and pastures in irrigation regions. So that was the main driver for the work. But of course, satellites don't have much regard for paddocks or farm boundaries and or state boundaries. So included in the information that we were collecting, there was information on a couple of ecosites on the Murray in particular, including the Hatter and the Barmer ecosites. So as a throwaway, if you like, we got some information that we could compare with the farming system, the irrigated farming systems that referred to the Hatter and the Barmer systems. So the approach basically was, yes, very much to investigate the application of metric. That's a particular algorithm that was developed over a period of time from, yes, that was used to, been produced in America to estimate ET of crops and irrigated crops in particular. So that was the main part, that was the main emphasis of the project, that and to apply that to associate, so we want to associate those ET measures with land use, on-ground weather and the vegetation status of what we're looking at inside paddocks or areas on the ground. And the vegetation status revolved around the associated measures of NDVI, which is the most common measure of vegetation status in the satellite world. So land use, the ancillary data that was used, this is where Mohammed and the spatial scientists really come into their own, well, way beyond my appreciation of what can be done. But so the land use information was derived from the likes of Sunrise 21 up in the Sunraysia region and or the Goulburn Valley horticultural censuses that are conducted or were conducted on a routine basis in this part of the world. So there was some land use information we associated with the ET maps, and we needed to take account of the weather at the same time, so we were collecting information at the time of the satellite overpass as to what the weather was on the ground. That was, and there that was the measure of evaporative demand at the time of the overpass was measured as ET0 or ETR, the difference being they're different versions of evaporative demand. The vegetation status, as I said, was measured by NDVI, which is standard measure. So this is a simple example of the map, if you like, of ET derived from satellites. And I was just going to give this as a throwaway, but people from this part of the world recognise this very well, that we have the, if I can work this, there it is, it's up on the back wall. So we have the Goulburn River channel, Shepparton just here, we're about in there somewhere. This is Shep East Orchards, the Ardmona orchard area. But you can see at the end of the drought, this was a measure at the end of the drought from the satellite, Waranga Basin. But a large part of the water use at the end of summer was associated with the river channel, and there was still some irrigation, very limited irrigation, associated with very much with orchards, Broken River here. So that's the sort of information we were using, and the likes of Mohammed and his team were associating that with land use. And this is the sort. So once you overlay land use, we have individual paddocks. We know what from the land use, the other information associated with those paddocks. We know what's being grown in those paddocks. So all in all, and of course we're measuring the weather at the same time. Oops, I just gone one too far. So basically, we're combining the satellite information with the ground-based information, the weather information at the time, and we're trying to make some inference about how water use is related to what's happening on the ground. That's the principle. And when we started to look at the riparian systems, the appropriate land use maps were the maps of EVC. So where did we get the same sorts of response? I've skipped a few here. So this is the, sorry about this, I'll take you back a little bit. This is the response typical for crops and pastures. And what we got was and what you see is up here we have the rate of water use, if you like, in relation to the amount of vegetation on the ground. And what we see typically for crops in irrigation areas is there's an increase in the rate of water use with the amount of vegetation as seen from the satellite. That's the basic relationship. And this was, there's a couple of examples there for horticultural crops, but this was repeated so often that it became monotonous. And with some minor variations. So, and we started then to compare what we were seeing with some early reports of what was published for irrigated crops in America, which showed that ET, NDVI, the high rates of ET were associated with a whole range of NDVI, depending on the amount of water in the system. But basically, the Americans said that all the observations should fall of irrigated crops could or should fall in this triangle, and that's at the base. So that triangle there is enclosing our observations. So how does this apply, for argument's sake, to riparian systems, which are described in our terms by EVC maps? So the one on the left is just the general relationship that we saw for one image at the end of the drought for Barmer Forest. That there's a lot of points there that you can see how they relate to the triangle, that ET in the forest is very much associated with that same triangle. Few major points of differentiations. That here we have some observations that rates of ET are higher than expected of irrigated crops. That high rates of ET are expected where there's water on the ground over here. And in some cases, there's evidence that there's that the vegetation, as shown by the header, for argument's sake, is lower rates of ET in some of the vegetation than expected on the basis of irrigated crops. So basically, we have a framework via this triangle that says that we can start to relate the expected water use in these systems, both irrigated crops and the ecosites, to the NDVI. But we can do. But we can do a little bit better than just the composite. Each of these. So there's one point I missed, that each of the points in the crop diagrams related to field averages of NDVI and ET. In this case, we have apparently a lot of observations for the ecosites, because each dot now represents the 30 metre by 30 metre estimate that Mohammed was talking about previously from the satellite. But basically, so now we're looking at I wasn't born knowing what the symbols refer to, but GW, WV is wetland veg, so we can have a look at the responses on each of the EVCs that exist within within each of the ecosites. And these are the smaller areas in the Barmer where we're looking at the PG, LSW. One there is unnamed, that's the, I'll stay away from the terminologies. And with these data, because now we have a framework for interpreting this information, that we can make comparisons between sites. So, for example, is the RGW classification in the Barmer and the Hatter, are they comparable? Can we see similar responses in the different vegetation types, even though they may be different, a little bit different depending on who's done the classification? Plains woodland for Barmer and for Hatter. So that's one sort of comparison that can be done, so we can start to understand qualitative changes, what's happening within the ecosites, but also we can do analyses of changes over time. So the previous data came from the drought in the 2008 area, and they were so we went, or Catherine Sheffield, another member of the team, went back and compared the images from 1993 pre-drought with the post-drought data. And for the end of this is the vegetation response now. For the vegetation response, big changes that range from a large decrease to a large increase. And the equivalent changes in the ET were similarly mapped. I won't go into the detail there, but in some cases there were decreases, some cases there were increases. You can see that the increases where the rates of water use were greater after the drought than before the drought, were associated very much with waterways within the forest. And the overall conclusion from those sorts of analyses was that the NDVI decreased, the amount of vegetation decreased during the drought in most of the EVCs, but more important, or just as importantly, the rates of decrease seen in the rate of water use of the different EVCs was more sensitive and decreased to a greater extent than did the amount of foliage. That means that the ET measures are providing us with independent source of information about the functioning of the vegetation in those systems. So overall from the project, that the understanding of water use requirements given us some information about for irrigators and how to provide minimal amounts of water to grow irrigating crops, and the potentially an improved ability to ensure environmental water allocations are meeting the needs of environmental assets. That water management can either be in terms of flooding needs, as Mohammed was describing, that the and or the baseline water requirements of different vegetation to maintain canopy cover, to maintain the operation of the systems in terms of providing the water for the use by the existing stands. Those relations, and the sources of water available to vegetation in the natural systems can be either the surface water and or rainfall, and we can investigate the maps and the responses that we see in the different vegetation classes in terms of rainfall, the hydrograph, distance from water source, and start to understand the operation of the hydrodynamics within these systems, which we can't do at the moment. So I think that basically we can do two sorts of things with these data, and that's the basic asset monitoring, put numbers on what's there and write reports about it and talk about condition and so forth in terms of both the water use rates and the amount of vegetation that's there, what the condition is. But also we can start to tackle getting a better understanding of water or water limitations on the different within these assets. So we can start to build up our information and understanding of how these systems actually work. So reversing those, I think that for natural resource managers, this is the final slide, I think, that satellite data are a key to improved understanding of water use and water management by systems within the high-value eco-sites, and they offer an affordable, routine, objective, etc., monitoring assessment of resource condition and water status. Thanks.